So today I will talk about level pool routing. This is an example of hydrologic storage routing. This is an example of hydrologic storage routing and also reservoir routing. So I have already discussed about what routing is and what are its classification, what is hydrologic routing and what is hydraulic routing. So we are level pool routing. We will discuss this as a hydrologic storage routing. This is basically an example of hydrologic routing. So what happened is, suppose this is a dam, and suddenly due to a flush rainfall, the flood waters enters the dam as inflow. So what it can change is, when a flood water is incoming to a dam, it can change water surface elevation. Correct? Water surface elevation, because the excess water will increase the water surface elevation, right, or the water level. And what more it will change? It will change if we open the gates of the dam. It will change the rate of outflow, and also the storage. So both the storage and rate of outflow, if you see, is a function of this water surface elevation. Because due to the flood water, the water surface or water level is increasing. So storage is also increasing. And if we open the sluice gates, then the rate of outflow will also increase, because of the potential energy it has due to the increase in water level. So both the storage and rate of outflow is a function of sorry water surface elevation. However, water surface elevation is function of time, because this flood water, when it is coming, time by time it changes. Correct? You see, if this is the rainfall, suppose this is not rainfall, but I am taking an example. So when rainfall occurs, suppose from this point, it starts to increase and then dips out. So this is the pattern of rainfall, this is the property of rainfall. So the runoff generated due to that rainfall, and which is coming inside the dam as a flood water, this will also change the water surface elevation. And this change will be a time dependent factor. Because as you see, at 12 o'clock there is X amount of rainfall, suppose. And in 12:30 there is X1 amount of rainfall, it has reduced. Then at 13, X2, 30, X3, 14, X4. So this is around 12 to 3:30. So 3 hour 30 minutes duration rainfall. That is just take an example. And you see X1, X2, there is a change with respect to time. X1, from X1 it has goes to X2 within 12:30 to 1 o'clock. So basically what is happening, X2 minus X1 is divided by, the slope is like this time at 13 hours minus time at 12.5 or 12:30 hours. So this X, or this now this rainfall is converted to runoff, and it is coming inside the dam, and it will change the water surface elevation. So with time it is changing. So this water surface elevation is actually a function of time. Now this storage is a function of water surface elevation, rate of outflow is a function of water surface elevation, but water surface elevation is a function of time. So you can easily write that storage is also a function of time. Rate of outflow is also a function of time. And suddenly water surface elevation, or just E, is also a function of time. So this is the transfer function or basic schematic of this thing. You see, this IT is actually the incoming hydrograph. The hydrograph of incoming flow towards the reservoir. This is our reservoir. So you see, due to this incoming flow of water, the storage is changing. The water surface elevation is changing. Here the water surface elevation is represented by H. H represents water surface elevation, and Q is very popular, as all of you know. Q is the discharge, and S is also very popular. S is actually the storage of water in the reservoirs. So now what happens is, you see, this Q and S both are a function of H, that means the water surface elevation. But water surface elevation is actually a function of time, because it is actually a function of this incoming hydrograph or incoming flow, this one. So this is a function of time. This incoming flow changes with time. So the rate of change of water surface elevation is also based on time. So this water surface elevation is a function of time, or a time dependent variable. And as this water surface elevation is changing or influencing this discharge and storage, we can write that storage discharge is also time dependent variable or dynamic variable. Now this also follows the law of continuity and momentum. In the previous video on routing, I think its name was Basic Equations of Routing, you can find how this equation is coming. So actually what is happening is, it shows that the average inflow at point I, let us say, within del T. Del T means the change in time, T1 minus T2, okay? Is if you deduct the average of outflow from the average of inflow for a certain duration del T, then you will get del S. So this is actually from the continuity, law of continuity. But however, this equation can be rearranged and written like this. And this is valid for some spillways which are uncontrolled. And which are the uncontrolled spillway, or rather, what is spillway? Spillway is actually the pathway or the arrangement in a dam to release surplus water. To release surplus water, or the water which can overflow. So to release that water from the dam, there is some arrangement made. So that arrangement is known as spillway. And the discharge to the spillway is represented by this equation. for an uncontrolled spillway. Uncontrolled means this spillway is not controlled, not regulated by anything. So the flow of water is unhindered. So if you see the structure of dam, this upside of dam is known as crest. This is the hill, right? This is hill, the base of the dam. This is the toe, just like human being. So these are two supporting points actually. And this one is sluice gate, and this is the spillway. This is the path for passing the excess water, because you see this is the normal water level. So if you want to release some water when the dam has a water level which is equal to or below normal water level, you will use this part. This is known as sluice way. Sluice and spill is something different. Sluice means which we want to release deliberately, systematically, because we have water and it is not overflowing. As and when required, or as and when a demand is created, we can release this water through the sluice gate. But spillway indicates spilling of water from the dam. You have a bucket full of water. You continuously pour water into that bucket, continuously. What will happen? That the water surface at the bucket will start to increase, water surface elevation, and it will goes on increasing, and ultimately, due to the finite size of the bucket, it will overflow. So as this bucket has no special arrangement to control this or to release this overflow, so it will just abruptly fall from that bucket directly to the bottom below. So for this, what will happen? There will be some hydraulic jump when the water reaches this field, ground, and some hydraulic jump will occur and the water will get scattered out. And also this portion of the ground will be damaged due to the force of the water. Okay, so but instead of this, if you provide this bucket a special arrangement to release the overflowed water, that arrangement is known as spillway. Okay, spill means overplus water, surplus water, or overflowed water. That is spilling. So when a water spills out, we say water is spilling out of the bowl, because you are constantly adding water, and now the volume of water that you have put into the bucket exceeds the volume of bucket. So it is spilling out. Okay, so from that it comes spillway. And when spillway is not controlled, you can use this to measure the discharge of water within that spillway. Provided here we are talking about those spillways which are open channel. That means it is not closed channel. The surplus water do not pass through the closed channel or closed pipe. Always open channel is used to supply water or release water or to discharge water. Okay, so if that is the case, that open channel is uncontrolled also, without any gates, without any control, you will use this equation to find the Q. The CD is coefficient of discharge. This G is actually acceleration due to gravity, and L is the length of the crest. L is actually the effective length of the spillway crest. So I have already discussed, if this is the spillway, the length of the crest is actually indicated by LE. And this H is actually the head over the spillway. So that spillway will also have some head. So that head over the spillway, the effective length of the crest, spillway crest, acceleration due to gravity and this coefficient of discharge along with some this 2 by 3 and 2, we will estimate the uh, discharge which is a function of water surface elevation H or water level. Okay, so to calculate the outflow hydrograph, routing, as you know, is you have to predict the outflow hydrograph. You have the inflow hydrograph. Along with that, if you have the initial values of the storage in the dam, the inflow that is taking place, and of course the outflow at time t is equal to 0, initial time of the survey, you must have them because these are the main boundary conditions, right? So you are giving the value of this ASI and 0 at the required time t is equal to 0. You will also require this inflow hydrograph. You will also require in the rating curve, which indicates the water surface elevation versus outflow or storage. Basically, it is a rating curve, and rating curve is water surface elevation versus outflow, okay, or storage versus discharge. That is also valid. Either you keep the curve elevation versus outflow, or you give the curve as storage versus elevation. Right, so elevation is common, and the storage of the reservoir. Now there is a curve for that, storage volume versus elevation of the reservoir. So similar curve like this is there. So that is also required, storage volume versus elevation of reservoir. Second is water surface elevation versus outflow curve, or to be more precise, storage versus discharge curve, correct? Of course, the inflow hydrograph is required, and also initial values of storage, inflow, and Q at time t is equal to 0, that is the initial conditions. That also required to be provided to this one or to this one. But to use this one, you need to know trigonometry, you have to integrate, and then you find something which is of interest. But to predict the outflow hydrograph, in this case, when there is a flood hydrograph as input, then we require the storage versus elevation of the reservoir, water surface elevation versus outflow or storage versus discharge data, inflow hydrograph, and initial values of storage, initial values of storage, inflow, and outflow at time t is equal to 0. That means at t is equal to 0, whether any water is coming out or not, whether any water is coming out of outflow also. Okay, so this is what in brief level pool routing is. Yes, level pool routing has two different methods of doing it. It has a semi-graphical method, and it also has a simple arithmetic calculation or calculation based method. Okay, so yeah, there are in the next few videos, I think within the next 3 videos, I will discuss about the 3 hydrologic routing method, namely modified pulse method. One is there, modified pulse method. Another one is Goodricke method, and there is also a what I would say is a Goodricke method is there. Now the last method is the 4th order Runge-Kutta method or SRK. Okay. So in this three methods, two are numerical, completely numerical, and one is graphical, or rather semi-graphical. So with those three methods, you can easily solve the problem and find the output hydrograph here. And as I was saying, what is this picture about? This is the discharge versus duration graph showing. This is also known as hydrograph, very popular concept, hydrograph. And here they are showing that how the discharge is increasing. Okay, because more the discharge, more it will be difficult for wild animals to sustain. So you see, this is increasing. Why? Because of some inflow of water, which is increasing its discharge. But why it is increasing its discharge? Because you follow a reservoir system, and the water is storing here continuously, and now it is showing spilling because the inside storage is not adequate. So that is why we say that storage is a function of elevation or water surface elevation. More the water surface elevation, there are more water, certainly. Less the water surface elevation, there is less water. And also rate of outflow elevation is different. So with this, I conclude this very short tutorial on level pool routing. So in short, I will give you a recapitulation also. So in short, or in summary, what I can say about this lecture on level pool routing or hydrologic storage routing or modified pulse routing. That is, modified pulse routing is one of the routing under this classification, correct? So let us start the summary. Summary is like this, that when a flood water is coming inside a dam, it is changing the water surface elevation of the dam, and due to this change in water surface elevation, storage is changing, and if we open the sluice gate, the outflow is changing also. But however, as this flood water is coming slowly but steadily, or coming rapidly, but the coming of water is increasing different volumes of water inside the reservoir, which is changing with time. And due to this change in volume of water, the water surface elevation is also rising or changing. So that is why they are saying water surface elevation is also a dynamic variable D. Now, water surface elevation is a function of storage, function of outflow. So the storage is also time dependent, outflow is also time dependent. So now their main aim is to find the output or outflow hydrograph from that dam. So for that, what they do is here also they use the continuity equation. So where it is stating that the average inflow multiplied the duration del T minus average outflow multiplied the duration del T is equals to the change in storage. And all the arrangement, calculation, differentiation has already been done. But this is the basic equation that is being followed. And this is followed for predicting the outflow hydrograph. But there is another thing is there, the flow through a spillway or spillgate or spillway, I would say rather, Q. Now this Q is for only uncontrolled spillway. So as you know what a spillway is the arrangement for releasing the surplus water. That is what is spillway. Okay. So this flow of water inside a spillway, which is uncontrolled, is given by 2 by 3 multiplied by coefficient of discharge. This is any value in between some constant and CD, right, multiplied by root over 2 acceleration due to gravity. Then you multiply it with effective length, and then you multiply with the H or head over the spillway. And that head H is carrying is this one. So discharge through a spillway which is uncontrolled is a function of coefficient of discharge, acceleration due to gravity, effective length, and depth or height over the spillway. So this is only done if the job is to find out the discharge in a spillway. However, in most of the case they will ask you to predict the output hydrograph. For that you have to use this equation. Other than this I do not know anything. Okay, with this I'll stop this lecture.